Imagine a massive, high-efficiency, 24/7 mega restaurant. The kitchen is fully staffed, the orders are flying in, and plates are moving seamlessly to the dining room. That is exactly what a healthy SAP system looks like for a large company. But if a power outage hits or a piece of server hardware fails, it is like suddenly losing that entire kitchen. Operations freeze, users cannot log in, and business stops entirely. When a company stops processing orders, they can lose millions of dollars in a matter of minutes. To prevent this kind of total shutdown, engineers use a system called clustering. Looking at this diagram of a standard active-passive cluster, you can see two identical servers, or nodes. Node 1 is our active worker, handling all the current traffic. Right next to it is Node 2. This is a fully trained understudy, sitting in standby mode, watching and waiting. By keeping a backup ready to grab the wheel at any second, the system ensures that operations continue smoothly, even if the primary server dies. To understand how this works in practice, we have to look at the different jobs inside that SAP restaurant. Let's start with the application servers. These act like the waitstaff. You will usually have multiple application servers running at once. Because you have a whole team of waitstaff, they already have built-in redundancy. If one waiter trips and drops a tray, another simply walks over and takes care of the table. But there is another component called the ASCS. Think of the ASCS as the head expediter. This central desk manages all incoming tickets, assigns locks on the pantry, and coordinates all communication between the kitchen and the dining room. Unlike the waitstaff, there is only one head expediter working the floor at any given time. This creates a single point where everything can get stuck. If that central ASCS stops working, the flow of information stops. Users cannot log into the system, and the different parts of the software lose their ability to talk to each other. Because the ASCS is so vital to the whole operation, it is the primary part of the system that we protect by placing it inside our cluster. When the primary ASCS fails and the understudy takes over, the waiters need to know exactly where to find the new person without missing a beat. The system handles this using a virtual IP. This virtual IP acts like a glowing neon order window sign. The waitstaff don't look for the face of a specific person, they just look for the neon sign and drop their tickets wherever it is hanging. Managing that sign is the job of the cluster manager. On a Linux system, this is usually a tool called Pacemaker, while Windows uses a tool called Failover Clustering. Think of this software as a robotic floor manager. This software has one job. It constantly checks the health of the servers and the network. It constantly watches the floor 24 hours a day, ready to act the moment it detects a problem. The virtual IP gives users one permanent address to connect to, while the cluster manager ensures there is always a healthy, working server standing at that address. Watch what happens when a crisis hits. The main ASCS server, Node 1, suffers a major hardware failure and crashes. The cluster manager registers the failure instantly. It sees that Node 1 is no longer responding. Without any human help, the cluster manager officially shuts down the broken server and moves the neon order window sign over to the standby server, Node 2. Next, the cluster manager wakes up Node 2 and automatically starts the ASCS services there so it can begin taking orders. The application servers see that the sign has moved and immediately resume sending their requests to the new active node. This entire automated process is called failover. The system heals itself in seconds, keeping the kitchen running before the business is ever impacted. This same logic is used in traditional data centers, where companies own their own physical hardware and connect it using local networks. It works the same way in the cloud, with providers like AWS, Azure, or Google Cloud. Even though the cloud provider manages the physical hardware, the setup of the cluster remains the same. While the ASCS coordinates the daily work, the restaurant's records, the actual data, are protected similarly. Just as a restaurant might sync its ledger to a backup vault, SAP uses technology like HANA System Replication to ensure the data is always available on the secondary server. Whether it is the coordinator or the data itself, the goal is always the same: detect the failure, move the resources, and restart the services automatically. SAP Clustering serves as a reliable system that keeps the modern enterprise running 24 hours a day, no matter what happens behind the scenes.
Don't forget to subscribe and press the bell icon.